Hi there, this is going to be another video about the false position method. So I'm going to speed things up here. As we always do, let's start with the function. In this case, it's going to be x cubed minus 9x plus 1 equal to 0. Now we're going to start with x1 and x2. Those are going to be my 2 points, and I choose those 2 points so that once I plug them back into our function, and they're going to give me a negative value and a positive value, or a positive value and a negative value. Anyway, they have to be opposite, so that if they are and the function is continuous, there must be a point in between in which the function is going to cross the axis, and therefore it's going to be 0. So as x1, this time I'm going to start with 2, and x2 is going to start with 3. So f of 2, if we plug 2 into our function, what do we get? Well, we got 2 cubed minus 9 times 2 plus 1. So 8 minus 18 plus 1 equal to negative 9. So it's a negative value, and now we expect from f of 3 to get a positive value. So 3 to the 3 cubed minus 9 times 3 plus 1, you get 27 minus 27. These two guys cancel out, plus 1, and therefore 1. So a negative value and a positive value, we're good. Therefore, I'm gonna not dry, I'm gonna draw a sketch here. So x and y of our graph, this is 0, this will be 2, and this will be 3. So we know that at 2 the function is negative 9, so it's like down here, like here. And at 3 the function is positive, so it's 1, so it's like up here. There we go. So we basically expect that if the function is continuous, that there must be a point in between this interval in which the function actually is going to cross the axis, and it's going to be 0. So once again, let me write the formula. So for the false position method, we have xr equal to x2 times f of x1 minus x1 times f of x2, everything over f of x1 minus f of x2. So with this in mind, we got x of r1, which is x2, so 3 times f of x1, so negative 9, minus x1, so 2, times f of x2, so 1. Everything over f of x1, so negative 9, minus f of x2, so 1. If we compute this, we get negative 27 minus 2 over negative 10, so negative 29 over negative 10, which is 29 over 10, which is 2.9. So now we have found 2.9, which I'm gonna put here, 2.9. And now we're gonna plug 2.9 back into our function and check and verify whether we got a positive or a negative value. So f of 2.9, if we plug it back into our function, we get 2.9 cubed minus 9 times 2.9 plus 1, so we get 24.39 minus 26.1 plus 1, so we get negative 0.71. So the function is actually negative, and it's like, I don't know, here. Well, it's terribly out of scale, but it doesn't matter, it's just a sketch. So negative 0.71, so it's negative. So we actually expect the function to cross the axis between 2.9 and 3. So we go on, and 2.9 is going to become our x1, and 3 is going to become our x2. So our xr2 is going to be given by x2, so 3, times f of x1, so 2.9, so negative 0.71, minus x1, so 2.9, times f of x2, so 3 will be 1. And then we have f of x1 minus f of x2, so f of x1 negative 0.71 minus f of x2, so basically 1. Okay, so if we compute this, we got negative 2.13 minus 2.9, everything over negative 1.71. Which gives us negative 5.03 over negative 1.71. So equal is like saying 5.03 over 1.71, which gives us 2.94. So we had just found our new value, which is 2.94, roughly over here. And now we're going to plug 2.94 back into our function and check whether it's going to be positive or negative. So f of 2.94, if we plug 2.94 back into our function, we're going to get 2.94 cubed minus 9 times 2.94 plus 1, which is going to give us 25.45 minus 26.46 plus 1, which is going to give us negative 0.01. So it's still negative, but it's like here it's very close. So it's negative 0.01. It's very close to be 0. So our best approximation for this function will be this curve here. There we go. So we could go on and do XR3 and so on. I'm not going to do it. But anyway, you know, 2.94 would be our new x1 and 3 would be still our x2. And we're going to find an interval between 2.94 and 3 and check whether it's going to be positive or negative and eventually get a value that is closer and closer to 0. But you know, negative 0.01 to me is pretty damn close to 0, and you know, we can stop here anyway. So I'm going to post a few more video about the false position method. So as I said, stay tuned. Bye for now.